And my name is William Denton.
And for our 221 final project, we decided to take inspiration from one of the earlier concepts we learned in class, which was k-means clustering, and apply it to the problem of image compression. And
So the motivation for this problem was essentially that conventional forms of compression sacrifice some sort of aspect of the image, and this is a central part in compression, but we were thinking essentially about how to utilize k-means clustering in order to compress images in a better way. So traditionally, you compress images by eliminating some of the channels, i.e., turning the image into black and white, or maybe by decreasing the number of pixels. But this, as you can see, results in a very pixelated image. So our idea here was to use k-means clustering to come up with a better way of compressing images.
And so for our problem, we wanted to come up with a way to cluster images based on colors in such a way that a classification model such as ResNet 50 could still have accurate results on the classification. So as you can see on the right figure, we have these clusters that are assigned to each color, and then for each pixel in the image, after the clustering is done, it will be assigned to that cluster center.
Yeah, and essentially each sort of pixel can be represented as a location in three-dimensional space with each color some value between 0 and 255, and then we're assigning each of those pixels to its cluster center, which is also some color. And our results were actually very promising. So in terms of compression factor, just as an example, if we were to use 8 clusters, that's equivalent to 3 bits, and that's instead of using 8 bits in 3 channels. That's how many colors we can represent with just 8 clusters, which is a 8x compression factor, which is quite impressive.
And so on the classification side, we used a ResNet 50 pre-trained classifier that had 99.5% accuracy on the CFAR10 dataset. And this was one of the challenges that we ran into because the CFAR dataset, the images are 32 by 32, and coming up with retaining the accuracy with the compression was a little difficult. So we decided to use larger images. And so on a subset of CFAR10 images, we achieved 20% accuracy on the compressed images.
But our qualitative results are a bit more promising. So we're able to get, as you can see, we're able to get some pretty high fidelity results of the original image with different sort of numbers of clusters, even as, we don't sacrifice too much in terms of compression factor. And in future work, we want to experiment more extensively with the number of clusters that we use in order to see if we can improve upon sort of the ability and sort of the fidelity of the original image.
And so also what we want to try is to use generative models to recover the original colors in decompression. So what we want to do there is take in the input images and use some sort of GAN to reproduce the output images from our compression.
And yeah, so that's what we've been working on for our final project. And thank you so much for listening to our presentation today. And we're really very excited about these results.